Hello, statistics and pre-calculus. A little reminder about what you already know about sequences. A sequence is an ordered list of numbers, and generally you can write a formula for a sequence in a couple of different ways. There are explicit formulas, which are basically functions whose domain is the set of positive integers, so you can find any term of a sequence anywhere just using the formula. There are also recursive formulas, which give you a starting point and a pattern, and that makes it easy to find a lot of terms pretty quickly from the beginning. So, an explicit formula for a sequence, this is the module we're in here, is a sequence exactly like a function whose domain is positive integers. So you can say what's the fifth term of the sequence or what's the sixth term of the sequence, but you couldn't say what's the 5.3 term of the sequence. That doesn't make any sense. So, here's an example from the skills page. Given the explicit formula, f of n is 3n minus 5. Find the first four terms, the 53rd term, whether 193 is a term of the sequence, and if so which, and whether 297 is a term of the sequence, and if so which. So A, I'm trying to find f of 1, f of 2, the first four terms, f of 1, f of 2, f of 3, and f of 4. So f of 1 is 3 times 1 minus 5, also known as negative 2. F of 2 is 3 times 2 minus 5. 6 minus 5 is known as 1 in most circles. 3 times 3 minus 5 is f of 3, that's 4. And f of 4 is 3 times 4 minus 5, all of them. 3 times n minus 5, so the first four terms of the sequence are negative 2, 1, 4, and 7. The 53rd term of the sequence isn't that much more complicated. The 53rd term of the sequence would be f of 53, which would be 3 times 53 minus 5. 3 times 50 is 150. 3 times 3 is 9, so 3 times 53 is 159. Subtract 5 and you're at 154. So someplace out here, the 53rd term is 154, and then you keep on going. Now, is 193 a term of the sequence? And if so, which? Let's find out. 193 is equal to 3n minus 5. This is part C. No problem. Add 5 to both sides. 198 is 3n. Divide by 3, and we get 66 is n. So yes, the 63rd term. Sorry, 66th term. On the other hand, 297, I know it won't surprise you to know that it's probably not going to work. 297 is 3n minus 5. Add 5 again, you get 302 is 3n. And now, divide by 3, and I get 102 thirds is n. It's not a term of the sequence. There's no such thing as a 102 thirds term. No, it's not going to happen. So no, it's not in the sequence. Good. That was an arithmetic sequence, a sequence that grows by adding, and the formula, the explicit formula, is very much like the equation for a line. Here's a geometric sequence, which grows by multiplying, and the equation is very much like the equation for an exponential function. So again, find the first four terms of the sequence, and the 10th term of the sequence, and all that. The first four terms of the sequence are g of 1, g of 2, g of 3, and g of 4. G of 1 is 3 times 5 to the 1 minus 1. So that's 3 times 5 to the 0 power. 5 to the 0 power, anything to the 0 power, is 1. 3 times 1 is 3. G of 2, 3 times 5 to the first power is 3 times 5, 15, because we plugged in 2, and it's 2 minus 1 is the exponent. G of 3, the exponent is 3 minus 1, so the exponent is 2. 3 times 5 squared. 3 times 25 is 75. And G of 4, 3 times 5 cubed is 3 times a big number. 3 times 125 is 375. The 10th term of the sequence. I don't have my calculator with me. The 10th term of the sequence is going to be a challenge without a calculator, but we'll do it. the 10th term is 3 times 5 to the 10 minus 1. 3 times 5 to the 9th. And I don't know what that is, but we'll figure out whatever number that is. It's a big number. Question C. Is 5,342 a term of the sequence, and if so, which term? Let's do it. That we can even do without a calculator. Is 5,342 a term of the sequence? 5,342 is 3 times 5 to the n minus 1 power. So, divide both sides by 3. No surprise there. Divide by 3, and I get 117. I get a whole big crazy thing. 17 is 224. 178. 0.666 equals 5 to the n minus 1 power. Is any power of 5 going to be equal to 1,780.666? I think not. Not a term in the sequence. Had we been clever, we could have figured that out right away, actually, because you notice the sequence is 3, 15, 17, 75, 375. You're multiplying by 5 each time. After the first term, every term ends in 5, so there's no way that 5342 could have been a term of the sequence. 1875, on the other hand, just might, because it does end in 5. So is 1875 equal to 3 times 5 to some power, to the n minus 1 power? So divide by 3, 625 equals 5 to the nth power, to the n minus 1 power. And yes, 625 is a power of 5. That's 5 to the 4th. 5 to the 4th is the same as 5 to the n minus 1. So that tells you that n is 5. It's the 5th term of the sequence. It's actually the one right after the one we previously did, after 375. If you multiplied that by 5, you would get 1,875. So it is a term in the sequence. There we go. Good for today. Well done.